Good morning to you all, colleague lecturers, professors, senior colleagues, students, industry personnel, people from the Chamber of Mines. Today is the first weekly webinar presentation series by our Ghana Chamber of Mines and Tertiary Education Fund Awardees. This week, we are going to have two presentations from Professor Richard Amorin and Mr. George OKai. But before we start, I would like to invite the chairperson for the Ghana Chamber of Mines UMAT chapter for her to give us the opening before we start the presentation. Thank you very much. Prof. Grace, please. The floor is yours.
Thank you very much, our Honorable Doug Ziga. Thank you so much for the brilliant ideas that you bring onto the table of the GCM-TEF UMAT committee. We are very grateful for the innovation. Good morning, our audience, and welcome. This is the first of its kind, though we have done some in the past, but those ones were more like you go through the project, finish, and give your presentation. You go on the internship, finish, and give your presentation. But for us to do some due diligence and keep to the schedule for especially the Staff Research Fund, so that we'll be in good standing for the chamber to keep sponsoring this project or this aspect of support from the TEF. It has become necessary that we institute the progress report webinars so that from our part as a committee, we know that we are on course and we will be able to report back to the governing board. And on the side of the researcher too, at least it keep you on track so that you are reminded that you need to report back every 3 months or quarter. So it's the reason why we are here today. We have full support from the governing board and the Chambers Council to be doing this because indeed, they were also getting a bit worried that for the awardees that came on board last year, the year has ended, basically, and we don't have any reports coming off. So I believe it is good for all of us to embark on this. Apart from what I have enumerated, the other thing is that it educates those of us who are not on the fund. We also get to know the brilliant researchers that our colleagues and our students are doing. So the presenters today, I welcome you and thank you for at least agreeing to be the pace setters. We are ready to listen to you. Good luck with your presentation, and our audience, I hope that we will all enjoy and also learn from it. And it will encourage those of us who have not benefited from the fund to also write and win some proposals the next time the call comes for us to apply for the fund. Thank you very much.
Thank you, Prof, for your opening. At this juncture, I will invite Professor Richard Amorin, who is going to present on the topic Safety Assessment of the Existing LPG Supply Chain for Safe, Sustainable, Clean Energy in Ghana, a case study of Western region. Prof, you have 20 minutes for your presentation and then 10 minutes for questioning. So I will unshare my screen and then will allow you to come on board. So, Prof, please, the floor is yours. Thank you.
All right, thank you very much for the opportunity. So I would first of all would like to appreciate the Ghana Chamber of Mines supporting our project titled Safety Assessment of the Existing LPG Supply Chain for Sustainable Clean Energy in Ghana, a case study of Western region. My co-PIs are Professor Eric Bruni Bediakon and Dr. Eric Stern. So this will be the presentation outline. LPG, as we are all aware now, has become an integral part of our energy mix. That's especially the domestic energy sources. According to the 2021 Population and Housing Census, LPG, as at 2010, 18.2%, and in 2021 rose to about 37%. In terms of the LPG is either imported or produced by Ghana Gas and sent to Quantum for further distribution by their BRVs. It gets to the refilling plants. Then the users go there to purchase. NPA is trying to work something with Girl so that we have the LPG retail plant. So we get our gas and we use them for various reasons. Though the latest statistics indicate that we are about 37% in terms of access, government is trying to move access to about 50% by 2020. And this has seen these establishments of various refilling stations. We have over 650 across the nation. We've also seen that the transport sector has recorded high consumption. We've seen that vehicles which were originally designed to are now running on LPG. So they have to run on LPG for various reasons. Sometimes this is what users are compelled to go through when there's a shortage. They need to queue for the gas. However, we have experienced several casualties with the use of the gas. So we have explosions, we have other explosions, accidents on our highways by the tankers. This happened not so long ago on the Tema motorway. Some burning to ashes, homes, workspaces burnt because of the use of the gas. So the question is, what is the challenge? LPG is very flammable. It has caused a lot of casualties as we see death, burns. The Reconstructive Plastic Surgery and Burns Center of Ghana has reported that on an annual basis, LPG accounts for 33% of all burns cases and 44% of all burns-related deaths. So is it because of low education or poor facilities used, or both, that is causing all these casualties we're experiencing in the nation? This happenings actually hinder our sustainable energy for all policy by the government of Ghana, SDG 7, 9, and 13, as these casualties causes fear and panic among citizens, and also, in a way, discourages them from using the cleaner energy to using high carbon footprint fuels such as firewood or charcoal. So the objectives of our work was to try to identify the safety and technical related issues associated with the existing LPG supply chain. So we assessed the knowledge of domestic and commercial users of LPG, also the tanker drivers, those who carry the gas from one point to another. We assessed their safety knowledge. And also we assessed the drivers, especially the taxis that have converted their vehicles from running on gasoline to LPG, knowledge on the use of the gas, and also recommended some ways of improving the current system. So in terms of methodology, we needed to visit certain places, spend some days, months there to pick enough information. We went to tour Quantum Terminal. We spent several months in Takoradi, and Sinkriga, trying to engage users. We used both open and closed-ended questionnaires to assist in our work. In terms of the safety knowledge assessments, we engaged 1,444 users, tanker drivers 178, LPG retailers, the attendants, those are the, should I say, the dispensers, at the dispensary units of the stations. We engaged 18. Then the people using LPG as their main source of fuel in their vehicles, we engaged 304 of them. And we also assessed over 1,000 cylinders to know their state, whether they are fit for purpose. Then we also assessed the refilling stations, usually with the help of the officers from MPA. We did that assessment. We did 12 stations, or we assessed 12 stations. For the purposes of our presentation this morning, being given 20 minutes, we would just concentrate on the work done on the domestic users. We've actually done we have finished assessing all the areas that we wanted to assess. So we hope by grace of God, we've been able to do that. So it's just about the reports writing and presentations. So for the domestic users, the 1144 users, we try to look at the educational level or background, and we realized that majority were educated from primary to tertiary, over 90%. So at least they could read, understand some facts about the usage of the gas. And one of the main reasons why they chose to use the gas was because they said it was quite efficient. So we went further to really understand or know from them whether they knew the material that was used to manufacture their cylinders. And we also wanted to know whether their cylinders were locally manufactured or imported. Some couldn't tell the state of their cylinder, whether they were locally manufactured or not, because some did not have any inscriptions on them. And that is a concern. Those inscriptions on the cylinders actually help to tell cylinders are fit for purpose or not. Aside doing those assessment, the integrity tests, physical evaluation, these informations are very key. Others said they bought their cylinders without these inscriptions and were wondering how those cylinders got onto the market to be sold to them. So for the locally manufactured, we had about 75%, imported about 25%. Cylinders that they didn't know their brand, we had about 54 or 55% didn't know the brand at all, which brand of cylinder they were using. Those that were not visible were 9.5%, and those who really knew the cylinder brand were 36%. One other key thing to identify to tell whether the cylinder was good for purpose or not is to know the pressure test date. The pressure test date. These are locally manufactured. So the pressure test date was in 2019. This one was done in 2012. So about 13 years ago. So this cylinder is imported. So before even it came, they've been using it. So how long has it been in operation? ever since it was manufactured. Per NPA's regulation, every cylinder should not be used for more than 10 years. It's not when it was put into use, but when it was manufactured. So that from the point of manufacturing to the point of usage, total should be 10 years. After that, it has to be discarded. However, in other jurisdictions, the cylinder will have to go for compulsory pressure test just to ascertain whether it's still fit for purpose or not. So that is one thing that we are lacking. Those who knew about this pressure test dates were only 9%. Majority did not know about anything called the pressure test. Then cylinders that had these inscriptions, at least they were quite visible. We saw about 18.2%. Some you can't see anything on the cylinder. Some is either on the ring or sometimes at the base or written inside, depending on the source of the cylinder. Those who had the pressure test dates expired were about 58%, and that is quite high. So in terms of the material used, we realized that about 62% or 63% didn't know the material that was used in manufacturing their cylinders. Those who knew were about 37%. And the majority of the cylinders in circulation were from steel. So this category, there's the aluminum and there's fiber. So as I mentioned, again, cylinders are not supposed, according to NPA, the cylinders are not supposed to be used for more than 10 years from the date of manufacturing, not from the date of use. So getting to know how they replace their cylinders, frequency of replacement, we saw that from 0 to 5, we had roughly 51%, 6 to 10 years, 37%. The rest do that after 10 years, which per the NPA recommendation is not practice. So we also wanted to know what motivates them to replace their cylinders. And reasons given were thefts. Some just replace for no apparent reasons. They feel like I've been using it for a while, let me just replace. Majority just replace. Majority was based on damage. So 92.1% gave reasons that the cylinders actually got damaged. That's why they replaced. Or only 1 or roughly 2% said because it has expired. Then wanted to know how they detect for leakages. And it came out that a lot of them rely on sense of smell, 75.4%, which is quite true because the LPGs do have special chemicals added to them, mercaptant. So if there's a leakage, at least you could pick that smell that the gas is leaking. However, if you have a bad sense of smell, you may not pick the leakage. And if also the wind direction does not permit you to at least pick the mercaptan in the atmosphere, you may not know that your gas leaking. Some also rely on the gasping of the sound that the gas makes when it is being released or leaked. The best way to detect gas leakages is by use of sensor, but only 0.4% rely on sensors. They have sensors to do that for them. Others also use soapy water. Other safety devices that are installed or part of the cylinder to safeguard the usage of the gas is the safety valve. This is very key, the one at the top, and this needs to be protected against damage. However, we realized that not everyone knew about this safety device. We had about, 81% knowing about the safety device. 19% didn't know about it. Then this safety device has a rubber lining, which serves as a seal to help you connect your regulator tightly to the cylinder so it doesn't leak. Usually when the seal is bad, that's when people put stones on their cylinders, and it's very unsafe because it may still leak. And once you have it leaking to its minimum explosive limit, which is about 2% ppm to about 8% or 10%, if there's a source of ignition, you will have an explosion. So this is also key that it has to be replaced frequently because it gets destroyed very often. So we wanted to know how often they replace their seals, and 25.5% said they do that anytime they are going to refill, or 65 also said they do that when it begins to leak, and we had 8.4% doing so only when it is recommended by the attendant. And we had 1.2 people not knowing anything about that safety seal. Then to also safeguard the valve, you also have to ensure that your cylinder has this cap, safety cap, to protect it when it's not in use. So it comes to cover this side. It's only 52% that had the, or 53% that had the gas in there. So this cylinder gets so heated due to temperature increase, or maybe there's a fire and the whole cylinder gets so hot, this device would open for gas to be vented out so that it doesn't explode. So if you don't protect this seal, then you are inviting hazard or a disaster. Other accessories that are used with the gas, especially the hose, the pressure hose, and the regulator. Other jurisdictions, this hose needs to be replaced every 10 years or frequently based on it suffers a lot of heat impacts, cuts, rodent attack, swelling. So other places is 10 years, but if only it's made of high quality material, but for the standard usually it's 5 years. However, when you buy the tube, it will have expiry date and other on it. The recommended practice is that from the date of manufacturing to whenever you got it, it should not be in the system for more than 5 years. So after 5 years, you need to replace it. And based on the survey, we realized that we had more than around 24% replacing the tubes after 5 years. After 5 years, not even on the expiry date or manufacturing date. It's just like maybe it's damaged. Either it's damaged or it's not helping with efficient flow of the gas. We just have, I think, about 1% placing due to the expired nature of the tube. And we have about 4.8 replacing due to routine maintenance reasons. Then in terms of filling the cylinder and transporting it home, filling and transporting. It is highly recommended not to fill the cylinder more than 80% of its holding capacity, so that the space at the top would accommodate for expansion. So in terms of filling, partial filling, we realize that 34% actually do partial filling. Then full filling, that is the 80%, that is about 65%. Then people who usually do overfilling were about 1%. When it came to the transportation, all cylinders must be transported in a vertical way. It should never be slanted. It should never be in the horizontal plane like this, never. It should always stand straight. And there's a recommended practice even to the transportation of the cylinders in the vertical stand or direction. But you realize that people just transport the fuel cylinders home anyhow. So I wanted to know what really influenced their transportation of cylinders in the way they do. And 61% said convenience, some space limitation. They couldn't just put the cylinder in the vehicle straight or in the vertical way. We only had 3.2% transporting their cylinders in the right way. So from this survey, those who transport their cylinders in the verticals, that were about 47 or 47 thereabout. Then in the horizontal, we were about 53. And this is very unsafe. That's very very, very unsafe. Typically, once the cylinders were arranged like this, it shouldn't have been filled at all. And they shouldn't have entertained at the refilling station. So we had people coming with wheelbarrows to carry in a slanted manner somehow, carrying. This had one at the back, one at the front, and the horizontal plane. Suppose the cylinder is to fill. It means there will be a very, in terms of the disaster that will be caused, will be very severe. So in terms of storing the cylinders at home again, the safest way to store the cylinder is to keep it outside, cage, and it should be under a shade. Even with this, the cylinder should not be very close to the windows or door spaces. It should be about a meter away. Should be about a meter away. But usually the normal practice has been once you get it out right under the window, you just put it there and you stop. Most users, majority were keeping their cylinders in the kitchen. About 52% in the open space. And that is also a very dangerous practice, very high risk. If there's a leakage, if there's a problem with the tube, it will leak. There's a source of fire. So this could result in an explosion. So we have a leak gas in the kitchen. You don't have to on the light. This is a source of ignition. Once you on, it sparks. So if there's enough LPG leaked into the atmosphere, the whole room could explode. So we had only 16.0% practicing the safe or recommended way of keeping cylinders at home. It should be outside and away from the window, about a meter off, and it should be under a shade and cage. So in terms of maintenance too, most of them were actually trying to maintain by cleaning or dusting. Others were spraying to reduce corrosion, which in a sense was very okay. Then in terms of rectifying cylinder problems, majority also consulted experts, especially the refilling attendants. 82% went for help. We had about 17% fixing their cylinders on their own. One of the best ways to fight LPG fire is to know exactly what to do when it starts. So I wanted to know if they know how to fight LPG fire. About 73% said yes. We had 27% saying no. Those who said yes said by use of wet blankets, about 24%. Fire extinguishers, about 62%. And not just any extinguisher, it should be Class B. It should be a Class B extinguisher, dry chemical extinguisher for fighting LPG. And that means, yes, that means we could use baking soda. We could use salt. Not so long ago, we've seen viral videos, people saying you could use flour. Flour is very dangerous to use. It's combustible. So you don't have to throw flour on LPG fire. Rather go for baking soda or salt. So if it's not a huge fire, then you could easily do that. We also wanted to know if they knew which office to call if there is an emergency, LPG related emergency. We have roughly 64% saying yes, they know exactly which office to call, the Ghana Fire Service units. So in this case, if you have a flame like this, all that you need to do is to get a wet blanket, not dripping with water. It should be wet, heavy enough. You just cover. The fire goes off quickly. You turn off the valve. If it's something you cannot fight, please don't try to use water or anything. If you have caustic soda, yes. If you have baking soda, yes. If you have salt, yes. If you can't fight it, please leave the scene as quickly as possible. So the other works that we have been able to do with the help of the officers from MPA, we visited the LPG refilling station. We assessed the layout, how they have constructed the whole refilling plant, the location, integrity of their storage tank, closeness to hot works. Some were very close to welding shops. Those were sources of ignition. Some had electricity lines running over the parcel of land. Others also had issues with electrical works, protocols, the way they receive gas from tankers and the way they discharge gas to consumers were also assessed, and they all had issues. We realized that they were not complying with the should I say the protocols. Their firefighting systems were also assessed, and we realized that in one way or the other they were lacking in their compliance with standards. Then we also assessed the safety knowledge of the flowing users, and we realized that they were unsatisfactory. The retailers, the pump attendants, those who discharge the gas, their level of education to safe handling of the there yet. The tanker drivers, those who move the gas from one point to the other, we've also assessed not very satisfactory. And also the drivers who have converted their vehicles to run on LPG, we also realized that they didn't know so well, or they didn't have enough knowledge on the safe use of the gas as well. So these are some of the shots from some of the stations visited. These are sources of sparks or ignitions. So if a leakage and there is a source, we could have a possible explosion. Housekeeping, not the very best. Usually once you have a LPG dispenser and the rest, it's not too clear yet. But these people had combustible materials used to do sealing of the sheet. That is not a good practice. It should be just open. The metal thing should be exposed. So if there is fire, it doesn't catch fire. We had a series of in-house keeping issues. The electrical cables, some of them were exposed. Some also had warnings for consumers. Some also did not have enough warning signs to warn consumers who come to the facility to purchase gas. Again, it's also not recommended that you use one dispenser to serve both domestic users and the vehicles, auto vehicles. It should be two. It should be separate. So one attends to auto, another attends to the LPG. And these vehicles, before you fill, you need to attach the fire arresters, but some two were not attached. Others were not complying. Transfer of leak cylinders to another. This too is recommended not to be practiced, but some were doing them. Some also had space limitation at their plant. So the discharge vehicles parked along the roadside and were discharging. If there is a leakage And once you have vehicles flying the road and their engines are running, those are sources of ignition. And once the concentration of the gas in the atmosphere hits its minimum 2 ppm to about 10, it will explode or catch fire. Most of the storage tanks in the system are, almost all of them were imported. And they were not used. They were not new tanks. They were used tanks which were imported. By practice, most of the tanks should be in the system for about 30 years. But you can never tell how old those tanks were before they were brought in. And they also be in the cloud. To get the actual information about the tank, there's a plate here that should contain the information. They are all hidden. It's rusted, it's been painted, you can't see anything. So the only thing to assess the state of the storage tanks are to run ultrasonic scans. And we saw some few reports based on work done either by Ghana Atomic Energy Commission. And we realized that year on year, as they come to do that, the tank keeps diminishing. And they recommend a new pressure holding for the tanks. So that was one other challenge with the current tanks we have for storing the volatile gas. And some too were undertaking repair works at the facility. These are all sources of ignition, which should not be entertained at the refilling plants, but they are doing it. So in conclusion, based on the domestic assessment, it's very clear that the domestic LPG users in the 3 cities lack enough basic knowledge on the safe usage of the gas. And also, most of the cylinders have expired mandatory service lives, coupled with wrong transportation, storage, and usage. It is therefore recommended that as the government of Ghana is trying to push access to about 50% by 2030, this drive should commensurate with efficient safety protocols to minimize the LPG-related casualties being recorded in the country. And also, it's very key also that most of the cylinders that we have in the systems, since they lack enough inscription to really tell or ascertain their true state, they should undergo frequent technical examination for fit for purpose verification, so that we are certain that they are good enough or safe enough to be used. And there should also be a review based on the other works done to upgrade the various protocols along the entire LPG value chain to guarantee public safety for the continual safe usage of the gas. On this note, we want to appreciate the management of GCM-TEF, especially the Faculty Research Fund Committee. Also want to appreciate the University of Mines and Technology for the opportunity, and the local GCM-TEF committee, all our field surveyors or field officers who were on the field for months to help us gather all these information. Thank you very much.
Thank you, Prof, for your wonderful presentation. Please, it's question time. You can show by hand through the Zoom. I'll call you, then you ask Prof your question. Yes, Dr. Adumako.
Yes, thank you very much, moderator. And Prof and your team, thank you very much for your wonderful presentation. In your presentation, you made mentions that keeping horizontal is dangerous.
Yeah.
I didn't get the reason for why keeping horizontal is dangerous. I don't know if you can Throw light on that. Why is it, if it is sealed, right? Yeah, I'll be grateful if you can expatiate on that. Thank you.
All right. Thank you. So if you keep your cylinder in the horizontal plane like that, you expose more of the, should I say, the gas to enough surface area. At this point, the surface area at the top is very limited. But if you turn it the other way, you realize that you now expose it to a larger surface area. And as you shake, the gas becomes agitated, excited. The gas is under compression. The gas in the cylinder has been compressed by about 250 times. So once you expose it to enough space, it wants to get excited. So it begins to move very fast, begins to build enough pressure in the cylinder. Now, if it's in the horizontal sense, enough pressure begins to build. And if there is a problem with any part of the cylinder, at least the safety valve is there. Once it hits a certain pressure, it should release the gas to keep the pressure in the cylinder. If that doesn't happen, the gas will keep building pressure. And if there is a problem, a defect in any part of the cylinder, because you have allowed more pressure to more or less be exerted or to be generated in the cylinder, that small leak or crack will open with force. And it will be like, should I say, a rocket that has been launched. It is just throw the cylinder, move it in any direction. And that is what actually causes a lot of the casualties. A flying cylinder can easily kill you. So the horizontal allows more agitation or more expansion of the gas because of the broader surface area now that has been created at the top. But this one would limit the space. So if even it's shaking, it's only this side that tends to allow the gas to build at the top. And that is a small space already. So this one prevents the expansion of the gas as compared to putting it in the horizontal plane, which allows more of the gases to become excited to expand.
Oh, I see. Thank you very much. Because my understanding from your presentation was, yeah, if you have the excitation and there is a leak, then yeah, you can have the casualties.
Yeah.
So then, is it not more about the leakage, which can even occur even if it is standing, than much about the excitation?
So yeah, so if it's standing like this, if at least the foot ring makes it stable when it's standing. And when it stands to, you need to chain, right? All these cylinders needs to be chained. You don't just put it in, it has to be chained. So if even there is an explosion or something, usually we are expecting that it should start from the valve. The valve should leak the gas. If this doesn't work, and maybe it's just at the side, because it's standing and chained, at least you still have the cylinder being held straight. So the gas will just vent vertically up. But if you just lay it on the floor, it's difficult to change again if it's this way. And these boats, as they begin to drive, this cylinder is likely to roll, hit the other side, roll back, hit. Then you realize that the gas begins to get excited. It begins to generate enough heat. It begins to build enough pressure. Then you have a bomb sitting at the back of your boat.
Yeah.
Yes. So that's a standardized, should I say, practice or recommendation. Everywhere there's a policy. Don't transport your cylinder in a horizontal way. places where they allow that, it's just they don't allow these massive or long cylinders. They're very short ones. And that one, they have distance limitation. So you don't have to move it beyond a certain distance. So if you want to move it in a horizontal manner, there's a space limitation. You can move that cylinder. But again, as you are aware, most of the cylinders we have in the system, we don't run the pressure test. So we don't even know that the gas in there and the material, the strength of the material that is holding the gas is even okay. That's why I've seen situations where someone filled a cylinder and was hooking with a cylinder. Then there was a leak. So quickly, the person chewed the cylinder outside. The cylinder did not land on the floor. It exploded in the air. So most of our cylinders, well, let me not say most, some of our cylinders for purpose. And therefore, the transportation too should be looked at very well.
All right. Thank you very much. Thank you.
Yes.
Thank you. Mary Ofori, please go ahead.
Okay, thank you so much. From the presentation, I heard that PRV is a safety device on the gas cylinder. Could you kindly elaborate on it, please?
That is the pressure relief valve. That's the valve here, or this. So if the gas in there becomes very excited due to heat, it begins to expand, begins to build pressure at the top. Now, to prevent the cylinder from exploding, the valve is supposed to vent out the excess pressure that is being built on top of the liquid. So the gas, when you go to fill the gas is under, though it's a gas, but it's liquid because it has been compressed. Once you begin to release or reduce the pressure, then it converts back to gas. So that is the nature of the LPG. So this valve is to help fill the cylinder, check the liquid in there, and also if you want to release, it's the same valve that will help you get the gas out. So that is the units. It's always on top of this in that. And safety valve. It's a safety valve.
So is it something you have to manually do from time to time?
No. So this is installed on the cylinder. Usually, if the safety valve is faulty and you will not be able to fix it yourself, though you can anyway, but it's not recommended you fix it yourself. Once you go to the refilling stations, the attendant, they do have a lot in spare. You will just unscrew this, so it has some thread. They will unscrew. Use the masking, not masking. They have a certain tip. They will tip around it, then screw it back so that you have a very tight connection. So your only duty is to make sure you have the cap on top. If you are going to fill, you cap it. After filling, you cap it. You also have to ensure that this rubber seal, anytime you are going to refill, you replace it. Otherwise, your gas will start leaking. And that's when people begin to put stones and other things on top of the valve. And that may gradually destroy your valve. So make sure once you are going to fill, one other way is that usually when you go and fill your cylinder, the attendant will put some soapy water around it to see whether it's leaking. Usually they are just checking the inside valve. Sometimes you can ask them to put some soapy solution, or you can do same just at the base here. And if it's leaking, you know that it is leaking. So you will have to protect it. And usually when you are transporting this cylinder vertically, horizontally, and you don't have this ring around, that means anything could easily break or cause a defect in the valve. So that is one thing that you also have to check.
Okay, 2 more questions, and Prof, you'll be done. Dr. Erico Forinto Jr., then from there, Ralph can also ask his question. So, Doc, go ahead.
Thank you, Dr. Zga, moderator. Prof, thank you for a wonderful presentation. I would like to know what, at page 9, slide number 9, you made mention of safety knowledge assessment, and you gave us some numbers as the numbers that you assess, where we have the tanker drivers, domestic users, LPG retailers. I can see that we have more tanker drivers than the retailers. I don't know what inform these numbers. Is there any scientific basic? Like, I know there are more retailers than the drivers.
Yeah, so thank you very much. So this work we did this in Takwa, we did some at Takrade, we did some at Asenkwigwa. So for the retailers are the people who are more or less rendering services at the refilling plants. So the pump attendants, we visited 12 stations. So actually, almost all the stations in Takwa we visited. We visited some also in Takrade. For Asenkwigwa, there are 2 there. One has been closed, so we only got to visit one, the remaining one. So it was based on a chart sheet we got from MPA, at least telling us where these refilling stations were, that we decided to visit. But when we went to realize that there were even others who were not captured on their data sheet or Excel spreadsheet, but they are there. So it was based on the information we got from MP, one of the officers, that we visited the various stations. And once we get there, we also try to engage, after doing the assessments, we also engage the retailers. For the tanker drivers, our main objective was to concentrate on the ones at Atuabo or Quantum Terminal. But we realized that they were not as many as we expected. Sometimes you just get maybe 4 or 5 only. And you needed to engage them because they travel all over the country. So anytime you go, you get some new drivers, you engage them. Then we also went to check to engage further tanker drivers.
Yes, I think, yes, that's why I was wondering why the retailers were not more than the drivers. Because when you have one station, you can have, I managed to work in that sector before, and we have a lot of retailers at the station. And sometimes we have a driver supply about 10 different stations. So I thought you get more retailers than the drivers anyway. And the last thing I would like to know is do you have plans to maybe organize a workshop for some of these retailers in Takwa? Because whenever I go there, I see a big issue at the filling stations that they even ask the domestic users as their customers to even fill more than necessary. And I always fight with them because I know what can happen with that. And once one of them told me that I'm too low, this Ghanaian thing. So with such an investigation or knowledge, I think organizing a workshop for the retailers in Takwa will be beneficial for the community. Thank you for your presentation.
All right, thank you also very much for the recommendation. In fact, it has to be a national agenda, because I believe what we have seen in Takwa, Takrade, and Senkwigwa will not be too different from other parts of the country. And therefore, we need to do a national education. We need to engage the people. Otherwise, we'll keep experiencing the casualties, losing lives, losing properties. polluting the environment. So yeah, it's a good call, and I think we'll work on that. Thank you very much.
Thank you. Ralph, please, you can ask. Prof, last question for you, and then we are done.
All right.
Thank you very much, Prof, for the wonderful presentation. My question is on the safety valve.
All right.
Yeah, I thought the safety valve is being done as or being constructed in a form of a non-return valve, or because when you are filling, you press it, it is being pressed against a spring to fill, and when you want to use it to, it opens against a spring. When you remove it, it closes. So my question is, if it gets excited and there is the pressure becomes higher, how does?
Yes. So the little I can see with the safety valve is, it is designed to accommodate a certain pressure. So you feel as you press the valve, the dispenser will press the valve, allow gas in. When you are also want to use, you put your regulator, it allows gas out. But when it's not in use, it's supposed to be closed. Now, if it's like what they do, normal processing with maybe flow lines, you get a valve, you give it a set point, that if the pressure in the vessel should reach that set point, it should open. It should automatically and vent out the gas. So it also has that mechanism where if the pressure in the cylinder hits that value, which is not supposed to hit, it's supposed to self-activate and vent out gas so that the pressure in the cylinder will normalize. Otherwise, it will explode.
Okay. Thank you.
Okay. Thank you very much, Prof, for your presentation. Please, you can unshare your screen. On this note, before I invite the second presenter, I would like us to acknowledge the presence of the Manager, Human Resource and Operations for the Ghana Chamber of Mines in the person of Madam Laurentia Boahima Ibua. We thank you for all the support you have been giving us. You've been with us from day one, and you have been joining all the webinar series that we've been hosting. Thank you very much. And I know at the end of the presentation, we will allow you to give a word or two before Prof will give us the closing remarks. So thank you for joining us. On this note, I will invite the second presenter in the person of Mr. George OKai, who is going to present on intelligent agriculture for alternative livelihood in mining communities. Sir, the floor is yours. Thank you.
Thank you very much, Mr. Chair. I believe you can hear me. Can I be heard?
Yes. Loud and clear.
All right. Yeah, thank you very much. So my name is George OKai, a technical instructor at the Computer Science and Engineering Department, and I'll be presenting on intelligent agriculture for alternative livelihood in mining communities. So this is the presentation outline. I'll be briefly talking about my introduction, the background and the problem identified, the objectives I set, the methodology and the methods that were used, the implementation, challenges, successes, and activities, alongside with our conclusions, recommendations, and acknowledgements. Intelligent agriculture is a new and emerging concept which involves the use of computer science and engineering technology into agriculture, drones, sensors, and other things, with the ultimate aim of minimizing human labor, minimizing cost, efficiency, and making agriculture more modern. That's the fourth revolution in agriculture. So that's what the concept of intelligent agriculture is all about. And our work is on intelligent agriculture for alternative livelihood in mining communities. So the background of our work is based on the launch of a national alternative livelihood program for illegal miners in the year 2021 in October, when the government brought about a major crackdown in the galamseyers. So the government at that same point in time was thinking of what else the miners who may be deprived of their livelihood can do, something sustainable. The government brought about this national program with the aim of giving them opportunities in areas like reforestation, areas like mine support services, and also one of the areas was on agriculture and agro-processing. So based on this, there's a committee in UMAT called the I-Agri Committee, that's the Intelligent Agriculture Committee, set up by Dr. Aganjiba, who was the head of department then, the year 2001. And our focus was to research into agriculture and look for suitable computer-based technologies that can support agriculture. So we thought of building up a proposal that will help us identify aspects of precision farming, smart farming, and digital agriculture, which can be applicable in the mining communities in line with the government program, looking for alternative livelihood for the galamseyers he wants to get off the fields. So we thought of designing and implementing workable models, which are appropriate within the program, and also looking at intelligent agriculture and developing training models whereby we train the youth. The government is going into agriculture with this youth, but we thought of, why don't you go a step higher? Because I-Agric, or intelligent agriculture, is the next stage of agriculture, whereby it's not the traditional farming with traditional farming equipment. We look at computers, sensors that make agriculture easier, smarter. So we develop our proposal based on the government project or the government program. So the specific objectives were for us to conduct research in the Takwa and Shuaim municipality and to identify specific precision agricultural technology that we can use or we can develop and train the youth on, and also to design and implement a working model of the right technologies based on the initiatives. So these are the objectives we set for our project. So the project we divided it into 5 phases. And the first phase was where we did some feasibility study, to find out what would be most suitable to do. The second stage or the phase was the design, development, and testing of a proposed system. And our focus was to be able to manage farms remotely and also manage environmental conditions on a farm. So we did a study. We came up with some designs, which I'll show you shortly. And the third phase was the deployment of the system on a farm. And we experimented with it. And the final stage was getting the data, report writing, and evaluation of the entire project, which is where we are at the moment. That's the 5th phase of the implementation. So this is a summary of the approach or the method we use, where the first phase is the feasibility study. The second phase is the design and development of specific prototype model, which was done in the laboratory. The third phase is the deployment of the model on an experimental farm, whereby we set up an experimental farm and deploy our models on it. We experimented the models in terms of the implementation of the I-Agric systems. And also we collected data, we are evaluating, and we are writing a report at the moment. So this is a summary of the approach or the method that was used. So I present to you our model. We developed our system based on this logic. And this logic is based on 2 subsystems. So it means we have a network of sensors which we planted. So on the top here, you could see that there's a network of sensors which we planted. And we call this the base station. So the network of sensors, they are soil sensors, which we plant in the soil to monitor environmental conditions like temperature, dew point, and other soil nutrient factors. And all this will be sent through the internet into the cloud, whereby it can be viewed on a laptop or a mobile device. And this same thing can be accessed by another microcontroller that will trigger a process. And the process is irrigation. That's when the water level in the soil and the moisture level in the soil is too low. There's this automation of triggering an irrigation that would help the farm to be well watered. And all this can be done remotely. So once the system is set up, you don't have to be there. You can only monitor and trigger the process, or the process can trigger by itself. So this is the logical design of the proposed system. And we have here how the system works. So you could see that there's a farm here with a network of sensors planted on the farm, picking the environmental conditions like humidity, dew point, the soil water content, and all that. And all these information are fed on a cloud service. And with this cloud service, you can access it and know the temperature of the soil and all that. And this same data can be fed into a water pump, which can be triggered based on the conditions which are presented to the system. So this is how the working model of the system looks like. So this is the physical layout of the system. That's the actual implementation we did, whereby you could see our demonstrational farm, our water reservoir is what you see there, the irrigation tubes alongside the sprinklers. And you could see here the soil sensor, which is monitoring the environmental conditions to trigger an irrigation based on what the situation or the data that would come. And this is just a typical example of one of the best. This is the Garden X bed, showing you some of the farming activities we did. And here we have our power bank on top of the microcontroller near the soil sensor on the field, the solar panel we installed, and also the water reservoir that we use for our project. And this is our first harvest, the picture of it. So with the implementation activity for our project, first of all, we sorted our permission from the UMAT estate officer, and we obtained a 50 by 60 meter land near Bangalore 21 at Government Hill. The experimental farm made up of 16 beds were created with high services. We were able to do tomatoes, garden eggs, sweet pepper, hot pepper, and cabbages. And the system were deployed and tested on the farm. The sensors were put at the various positions in the farm, the water pump, the water sprinkler, all that were done. For a period of about 2 months, we experimented and we got very, very positive results, even though there were some challenges, which I'll share with you shortly. So with the implementation successes, the Intelligent Agriculture System, which is Internet of Things based, that's IoT based, was able to monitor environmental conditions remotely, and irrigation was also able to be done successfully. The system was able to monitor the soil moisture and temperature in real time. The data from the sensors were successfully uploaded to the cloud for remote access by the farmer, and the smart irrigation subsystem also works smoothly, and the experiment was fairly successful. There were some challenges that were faced during the implementation, and the major among it was the poor soil quality at the chosen field, which affected the growth of the plant. We chose a field to experiment because of the equipment that were fairly expensive, And we were afraid that probably if we go far away from campus, they may be stolen. So even though the soil was not the best, we decided to go on with the project on it. Of course, we face challenges with the funding, since most of the items we bought were imported. And that was a point in time where the Russia-Ukraine war had really started and prices changed. So we're not able to buy all the items we needed. So we had to scale down a bit to achieve what we did. And also we had problems with security. Few of our items were picked. So we're not happy about that one too. And we're not able to get an accumulator. So the solar panel was not able to store the energy that we harvested. So we could only do the irrigation during the daytime. So it means if the system realized that the soil was still dry during the evening, it will not be able to water since there'll be no power. But in the afternoons, the irrigations were successful. So we are working on a scientific paper, which will be the specific implementation of IoT-based intelligent agriculture system in mining community. The draft is ready and is yet to be discussed at our level. That we will send it out for publication. So in conclusion, the project was able to go through successfully. The network of sensors we planted worked. They were able to feed us with real-time farm environmental and soil conditions, which we were able to display on our mobile phones and computers. The farmer or the demonstrational farmer was able to know what was happening in the farm remotely, and also the irrigation system worked successfully. And we therefore recommend that in the future implementation of the system, which we've well documented, first of all, we should look at the soil quality since it's affected the overall outcome of the crops that we planted. Of course, our major focus was the implementation of the smart technology on the farm. So we didn't really look at the soil and the farming management so well, but we believe that future implementation, such a thing should be considered so that you know how to manage it. And also for future works, we are thinking of integration of a weather model. The weather model works in line with the system we've created, whereby it will work such that the system will check the soil conditions. And when the system wants to water or trigger the irrigation, it will look at the weather forecast and check whether it will rain soon or not. If it will rain soon, it will delay the process for a while. And if it rains, it saves the water. And if it hasn't rained, then after a while, it waters. So that's what we are proposing for future implementation. And I would like to acknowledge the managers of the Chamber of Mines Tertiary Education Fund. Without them, we'll not be able to get the funds to import the items we needed to implement our project. We also like to thank the management of UMAT, TAQUA. I'd like to thank Dr. Emmanuel Ifa, who worked as a system designer and IoT consultant for the project, Dr. William Akuta Maganjiba, who was the former principal investigator and also the project manager, Engineer Mensa Siti, who worked as a system designer and analyst, Dr. Ezekiel Mate, who was a data analyst for the project. And we have a student called Georgiate, who was a research assistant, and a young gentleman who was interested in IoT works, which we brought him on board and worked as a research assistant. That's Amankwa Kwame Ajimai. Thank you very much.
Thank you, Mr. OKai, for your presentation. Please, it's question time. Any questions for Mr. OKai on the intelligent agriculture for alternative livelihood in mining communities? Yes, Ralph, go ahead.
Yeah, thank you, sir, for the presentation. I would like to know the total cost of the equipment and the installation, if you can give us the overview of the total cost.
All right, thank you very much. Our total cost was almost 75,000 Ghana cedis for the equipment. There's the irrigation system, the poly tank we got, the soil sensor, and all that. Cost us around 75,000 Ghana cedis.
Oh, okay. Thank you very much.
Please, any other question? All right. Okay. It's okay. There is a question here from Kweji.
Yeah, I think I have seen it.
Okay.
Yeah, I think he wanted to find out if there was
manual labor.
Manual labor in the yes, there was. We contracted one of our security men who is good in farm management, and he was the one who helped us in establishing the demonstrational farm in terms of the preparation of the 16 beds, and also he helped out with the nursing and the general farm management. I work closely with him. So yes, there was some manual labor in there. Thank you.
Okay. Please, any other question for Mr. OKai? All right. All right, thank you very much. Madam Laurentia, I don't know if you want to say a word or two before I invite Prof. Oforisapon to give us the closing.
Thank you, Prof, and good morning to everybody on the call. And thank you so much to our presenters. I think this is very educative, and personally, I have learned a lot. And I think these researchers are going to really benefit the industry and also the nation. But I would like us to move this forward and make sure some of these initiatives and recommendations are implemented. So I think Prof. Wisapon and I have been thinking about ways of getting some of the outcome of this research work to the larger chamber body. And after listening to today's briefings, I think it's very important that we find avenues. I would also probably suggest that when the chamber opens up and invites people to bring their papers. With that this year, I think we had one from the university, which we opened up. I think it was on Grinding Media, and it was presented at our conference. You know, the chamber organizes 2 conferences, which are alternated each year. This year was the Ghana Mining and Energy Summit. So one of the papers received from UMass, which was very strong, was given a platform to be presented to the whole chamber. So I'm recommending that next year, which is the larger one, the West Africa one, when we call for papers, maybe researchers should take advantage and present papers so that such works can be shared to the chamber body as a whole, and not just those of us at the Secretariat. As mentioned earlier, Prof. Oforisapon and I will continue to explore other avenues to make sure that such important work are actually implemented and not just end up being research papers. I mean, we need to have them implemented. And these will be my words. Thank you so much for inviting me.
Thank you, Madam, for your support as well. Prof, closing remarks.
Thank you very much. And thanks very much, Madam Laurentia. I see that she has said everything I wanted to say. But coordinator, can you at least remind us of when we are meeting again for this?
Okay, Prof. Next week, Friday, same time, 10 a.m.
Okay.
We are going to meet and we will have 4 presentations from the faculty members. So the flyers will come out and then the Zoom links to be shared. So next week, Friday, same time. Yes.
All right. Thank you very much. And presenters, thank you very much. I indicated that we were all going to learn from your research findings. And indeed, we have. And thank you to the audience for showing the interest to be here. And I'm happy to hear Madam Laurentia re-echo her interest in all these things. She's been working so hard to, help us move our research forward amongst other support areas that the chamber is giving. And I'm happy that she's also working on, getting slots for members to present to the chamber and indeed the whole world through the chamber's conferences. Thank you all for joining us and see you again next week, same time. Bye-bye.
Bye, Prof. Thank you.